All right, so I know we're doing C++, but I actually like doing a lot of my demonstrations of AP style questions that students get in their Java class. So part of it's going to be in Java, what it looks like, but that's just the problem set. We can do this all in C++, and again, I think they're good problems to think through, and they're kind of challenging. So we'll see how it goes. So this is a 2011 sound class, and we still haven't been writing objects or classes yet, but that's okay. We don't even need to. See what it says digital sounds can be represented as an array of integer values. Okay, so for this question, you'll write two unrelated methods. So these are functions of a sound class. So a partial declaration of the sound class is shown below. So and it's hard to kind of see because this is blacked out, but we're going to do this limit amplitude function and pass in a limit, and we'll do the trim silence from beginning. Okay. So it says the volume of sound depends on the amplitude of each value in the sound. The amplitude of a value is its absolute value. For example, the amplitude of negative 2300 is 2300, and the amplitude of 4000 is 4000. Write the method limit amplitude that will change any value that has an amplitude greater than the given limit. So when we pass in this limit, the amplitude that's in the array can't be larger than the limit. So let's keep reading. Write the method limit amplitude that will change any value that has an amplitude greater than the given limit. Values that are greater than limit are replaced with limit, and values that are less than negative limit are replaced with negative limit. The method returns the total number of values that were changed in the array. For example, assume that the array samples has been initialized with the following values. Okay. So if we pass in 2000, this would get changed to the 2532 would get changed to 2000. Negative 2300 would get changed to negative 2000. Negative 4000 would get changed to negative 2000, and 2030 would get changed to 2000. 3223 would get changed to 2000. So it would change 1, 2, 3, 4, 5 times, and that's what it would return as 5. And then now, in just my mind, I don't know, just when I think about electricity, like resistors make sure that the incoming electricity into your gadget doesn't, melt your gadget down. Maybe the same thing's going on with the amplitude, where if you get these large spikes, it could blow out your speaker or something like that. So again, I know nothing about speakers, but I'm just thinking, okay, that kind of makes sense. There could be something here that would limit that amplitude so that it wouldn't blow out my speakers. So there would be kind of a cool purpose for that. So, so write the limit amplitude. So my high school kids actually have to do this, they'll get their tests and they have to write this stuff right here. So, this isn't a hard program. This is one of the easier ones. But at the same time, being a high school student where this is your first year of doing this stuff and writing it out by hand, I think it's a pretty good challenge. It's not easy in my mind. So, because most of us, when we first start, we can kind of plug and chug and figure this out. So this was the 2011 sound class, so I'll call it main 2011 sound. So anyway, yeah, having a computer in front of you is definitely a lot easier than having to write this out by hand. So this is a good challenging problem for new programming students. So this one's going to be called int limit amplitude. So int limit, sorry, let me pause this. Sorry, my kids are outside going crazy, running through the house, so it was getting a little loud. So limit amplitude. So what does it say? Limit amplitude. Limit amplitude. Okay, so then we pass in the int limit. And what is it wanting to return? Num changes. Okay, so up here we would have, part A, where int num changes is equal to, and we'll call limit amplitude I'm spelling this all wrong. Limit amplitude. Okay. And we're just going to hard code it to pass in 2000, okay? I'm not going to do like C out and stuff like that. Now, I don't know if we're going to need this, but using name, we probably will. Namespace. Okay. And then I'll do this right here. So define my method. And so we will in here return num changes. Alright. And I don't know, I'll just do it up here. Int num changes and just set that to 0 at first. Alright, so that's part A. And then part B. Let's see what it's going to do. Just to set it up first. So it says, record sound often begins with silence. Recorded sound begins with silence. Silence in a sound is represented by a 0. Write the method trim silence from beginning that removes the silence from the beginning of a sound. To remove the starting silence, a new array of values is created that contains the same value as the original samples array in the same order but without deleting zeros. The instance variable samples is updated to refer to the new array. Okay, so we got samples. Well, I'm just going to call it samples B. Has all this stuff in it. And then, so we got to then create a new method that, chops off the first 4 if they're zeros. And then after that, you would put in all the other sounds. So it says what? Remove all signs from the beginning of the sound. Silence is represented by a 0. Okay, cool. So public void. So we'll just say void trim silence from beginning. Okay, cool. So void trim silence from beginning. And put this in here. All right, let's see here. All right, so then we're going to have our int, we'll call it samples A. And that's going to equal, and what do we got here? 40 2532 40 whoops. Okay. 17. Negative 2300. And I think it was 17 after that. Negative 17. What was that? Fourth? Negative 4,000. 2,000. And I think it was 1048. 1048. And then it was negative 420. 3315. 3315. I think negative 32. 2030 and 3223. Then 2030 and then 3223, I think. Okay, cool. All right, so we can now start our first one. So, let's think about this. So, samples A. So we got to just run through all of them, and if it's greater than our limit, then assign it to limit, and if it's less than our limit, then assign it, or if it's less than negative limit, then we assign it to negative limit. So we got to do a for loop for int I equals 0. Then I is what, less than. Ooh, we need to do the sample sizes, sample A sizes. All right. So int samples A sizes size is equal to the size of samples A. And then what size of samples A 0. So this will be what? Samples A size I plus plus. And then we just got ourselves a simple if-else statement. So if samples A at position I, so again, and this might help some of you, index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I always put a 0 on there to start it over again. So we got 0 through 9, and then, you know, index 10, 11, 12, 13. I mean, you can put it like that. I usually just do 0, 1, and then I know, you know. So you could do it, I don't know, whatever way you want to do it. So if it's greater than the limit, then the samples at that, so like for instance, when we get to this part in the loop, this is greater than what's passed in 2000. So we got to assign index position of samples A at index position 1 to 2000. Okay? Which is really just limit. So we'll say samples A at position I is now equal to the limit value. Okay? And then remember, the whole purpose of this, even though it seems like it's changing it, which it is, the whole purpose is to return the number of changes. So we'll say num changes plus plus. Okay. Now this num changes is actually this one right here, and this one is going to be equal to whatever this is set to at the end. Okay. So we'll say else. We'll say else if. Yeah. Else if samples at A is less than negative limit, then we say what? Samples A at position I is equal to negative limit. And then we do num changes plus plus to add up, another, so it would hit here, num changes, there'd be 1, hit here, right there, it'd be 2, then 3 down here, and then 4 right there, and then 5 right there. Okay. So, I think this works. What we need to do is do some testing. So we would do cout number of changes, and we'd say what? Num changes and L. And then also, since we changed up samples, I want to do a printout on that. So I'm going to do cout, and I'm going to do samples A, and then cout samples A at position I, and then just probably a blank space in between with a comma in there, and then so let's see what we got here. Whoops. Okay, let's try running that. Failed. Where am I wrong here? No. Else if number of changes 5, and so let's compare what we got up here. And you see where that error is. You can't have an else with a Boolean condition. It's just so the else if you can have. Yeah. So 42, so that changed to 2000, 17 negative 2000, 17 negative 2000, 2000. Okay, so that looks good. So it looks like samples A got changed, and the number of changes was 5. So that, that tests out. That's good enough for me for where we're at. All right, so so trim from beginning. Okay, so for part B, trim you know what? And I apologize. This is actually, and I wonder if I can view this stuff any lower. I haven't looked into this, but it's just, this is kind of small. I got bad eyesight, so if you feel like this guy's taking forever, I apologize. All right, so All right, so we're going to call that. And so let's think about this. We need to count up the number of leading zeros for this one. So these are our leading zeros. So we want to count those up to figure out, we know the size of this samples B is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 elements, index positions in here, or elements in here. But when we create our new array, we don't want this. So we want to figure out how many leading zeros are in here and subtract that from the array size of our samples B, and that will give us 12, and that will be the index, the number of elements in our new array that we're going to create. Okay. So first of all, we got to create our samples B. All right. So I'm gonna see if I can make this a little bit smaller, and that'll make it better. Then I'm not like going back and forth. So we're gonna say int samples B is equal to, and that's going to be 0, 0, 0, 0, 0, 1, 2, 3, 4, negative 14, 0, negative 35, negative 39, negative 7, 16, 32, 37, 29, 0, 0. And so then we need to do, another sample size here. Only this is going to be size for B. So we'll put B there, uppercase B. B. Okay. Should be fine. Make sure this runs. Yeah, there's no problem there. That's fine. Alright. So that's that. So that should get us through that part. So then what I'm going to do is I'll do an int value called leading zeros, and I'll set that to 0. Okay, this is what we're going to count up. And so we'll do while let's think here. While samples B let me think here. All right. For leading zeros, I'll show you what I'm doing here. Then we would do what? Leading zeros plus plus. All right, so this is a case where for loops, you have to know how many times you're going to run through it to use a for loop, and that's fine. A lot of the times, most of the examples I'm giving you, I know how many times I'm going to do it because it's limited by my Boolean condition. But there's times when that you might not know how many times you need to run your loop, and that's where a while loop comes in. So think about this. This, just by looking at this, we know that there's 4 zeros that are before the samples B. Numbers become either negative or positive, right? So there's 4 zeros. But there could be 5, 6, 2, 1, 0. There could be none. Okay, so we don't know how many that they're going to give us, so we have to program an algorithm that can figure this out. So while whatever we have at position 0 is equal to 0, then we add it up and we go to the next one. So that would be 1. And so then we go, to the next one. Whatever's at position 1, is that equal to 0? Yes, so add 1 more to it. And so it does this until it's not equal to 0, and then it's done. Okay? So that's what that while loop is there to do, all right? And that is, just going through that is a really good strategy for you guys to learn and think about, because these are kind of problem-solving skills where you're sitting here going, how the heck can I determine how many zeros are in here? Because I need it to count up all my zeros, which is 4, right? Because that gets us to the next part where I've got int, we'll say int, and then I'm going to create a, another array, and we're going to call it without leading zeros, okay? I'm just going to call it without lead, or I could call it sample C. I mean, I don't really care, but let's call it sample C. We'll say samples C. Now we need the size. That's going to be equal to our samples B size. Samples B size. Okay, I called it samples B size, right? Samples, there, samples B size. Samples A size. Okay, so those are samples B size, so that's going to give us our, 16. So if I do my index here, and I don't know if this helps you guys think through some of this, but, they sure didn't teach us this when I was in college, so the professor was, he was a very smart man, but no one understood him, so it was just kind of, So I realize I'm going kind of slow with these, but at least, you're going to kind of hopefully see how this stuff works, okay? So here's your 16 index positions. Any position is 16 minus 1 is 15, and there's our 0 position. All right, so that's going to give us 16. So we want to go 16 minus our leading zeros. Okay, so that's the algorithm to give us our sample size C. Okay, and why is that important? Well, that's important because we got to create ourselves a int samples C samples C what's it called, array. All right, now this is gonna look weird. Okay, with C++, okay, for these ones, for instance, I know the values, okay? I know what they are, and so I just plug them in, right? And they get stored in there. This sample C is dynamic, meaning I don't know the values yet because I have to plug them in by running a loop and plugging in all the values from 4 on, right? So because I can't just copy that and paste it into here, I have to run a loop. I have to be able to throw in the size of my array, the number of elements of my array. So this is a dynamic array. And so in order to create this, you have to give it the data type and then a star, and then you name it and you say new int, and then you have to have some sort of number in here. Because if I don't do that, should get an error here. Is it going to look and see? Yeah, well, I mean, if I start plugging stuff in, I'll get an error. I'll show you here in a second. So, the reason this is for is you can't just create an array with unlimited memory space. And so this limits it down to the number of items or number of index positions that you're going to have, have available for storage space, okay? So what we'll do is then we'll do another for loop, and we'll say what, int I equals 0, I is less than samples C size I plus plus, and then all we do is we say what, our samples C at position I is equal to our samples B at what? At I plus what? Our leading zeros. Okay, look at that. So this is 0 plus 4. Okay? 0 plus 4 gives us right there. So 14 will get plugged right in there. Okay? And then it will go, I will become 1. So 1 plus 4 would be 5. So 0 would get plugged into index position 1 right here in sample C. Okay? And so we did trim it, and we did assign this to sample C. So now what we should be able to do is yeah. So what we can do is just to just test this thing, we can do let's do this. Let's do C out, and we'll do samples C, and then we'll do what? C out, samples C at position I, and then same kind of thing right there. Alright, so let's run this. We will do this before this. We will say end L. See if it likes that or not. You might. Oh, end L. Alright, let's do that. So -14, 0, -35. Okay, cool. Now let's just look at this again. I wanna say this is not gonna run here. Let's see. Yeah, interesting. Alright, I'm gonna look into that. That's kind of odd to me because everything I was working on, this would basically give it unlimited amount of memory in my mind. So I don't know. This would set up our sample C with the number of elements it could store in it, because that would give us what, 12. 16 minus 4 would be 12, and that's, you know, what it should look like. So anyway, I've gotten errors in the past, and I'd have to look this up. But this solved them, and so it's interesting now that, you know, it's funny, I'm making the video, and that error that I've had in the past doesn't come up. But either way, it still works. So go ahead, plug this in. You know, maybe, you know, again, it depends on how far you want to take this class. If this is what you really want to do for your career, you know, knowing how to write this out off the top of your head, without the video, you know, that's something that you would have to do as a professional programmer anyway. Maybe not on paper, but being able to figure this kind of stuff out. And so, you know, I'm showing you what my high school kids can do. So, you know, if you're a college student watching this, you know, you got kind of an idea of your the up and coming competition. So, and it's I have some really bright high school kids. So, anyway, this video's done.